Hello everyone, welcome back to another video of Fun Up Quotes. This is Arunabh Agrawal right here, and in today's video I am going to be talking about something which has caused many of my problems to go wrong, and you probably have been doing this wrong, which is, well, reading problem statements badly. Alright, so let's talk about how one person can read problem statements badly. Alright people, so let's go over how I messed up this problems by reading the problem statements incorrectly. So for the first mistake, let's talk about this problem, which is Polly, carp and coins. So Polly must pay exactly n bulls at the checkout. He has coins of two denominations, 1 and 2. He likes both coins equally, so that's not a factor here. And basically we just need to minimize the difference between the count here, so that we can get the value of n here. Alright people, so what do we need to do is we need to make it so that 2c1 plus 2c2 just c2 gives us the value of n, where c2 minus c1 module absolute of course is equals to is the smallest. So this right here is the C2 minus C1 is the smallest. Now what I tried to do was I tried to utilize linear equations here. So what I did was I basically transposed this here. So like I'm taking the example of 1000 here. So like 2C1 plus 2C2 is equals to 1000. So what I did was I basically just computed. So if I can show you guys the code here, yes. So what I did was I basically just computed the code of the value of C1 with the basis of C2, and I tried to increase the value of C2. And while this code would definitely work, but it would take a lot of time. Like if I can explain you guys here correctly. So what I did was I just transposed the value of C1 here, and I did was n minus C2, and I just tried to then iterate over the value of C1, and then I tried to minimize the difference here. Now this code passes in the test cases, but this code is ON, and that brings us to the first mistake of our reading problem statements correctly, which is not analyzing the constraints properly. So the actual solution for this code is actually utilizing the modulus part here. This is basically we are just using the value of n modulus 3 here, and we are just distributing that across the two variables. So like n modulus 3, if case 1 if it is 0, then the value is like 0, then the value is like the value C1 and C2 is both this value right here. If it is 2, case 2, if n modulus 3 is equals to 1, then what we would do is we would just distribute the value of 1 in the variable of C1, which is the number of denominations of the value 2, and if the value of the modulus is 3, modulus by 3 is basically 2, then what we would do is we would just give it to C2 here. So yeah, that was the problem, and this gives us one solution, and that's what actually made this problem solve for me. But you might be thinking that what's the significance of both of these steps here? Now I actually implemented the linear equation step, but I could not implement the modulus step. And when I further realized the problem, I realized that I could have actually implemented the steps, but just because I did not go towards the optimization part of this right here, I did not actually do the effort to derive another solution. So yeah, this is basically the mistake which I was talking about. Alrighty people, let's talk about mistake number 2, which is just not reading the problem statement correctly and missing small keywords, which would result in a wrong answer. Now let's read this problem. So AI is belongs to okay, And what we need to do is we need to check whether the array can be strictly increasing in order or not. Basically what we need to make sure is that no array is not equals to array I plus 1 or array I minus 1 is not equal to array I, and this is basically to be checked in a sorted array. Now this problem is super easy, but I misread the problem statement here. So this is actually the what we are supposed to check for, right? But what I did was I basically checked for the entire array and I maintained one boolean right here. So like it was a continuously varying boolean right here, but that would result in a wrong answer. While what we need to do was, if we find a equal pair, we just like break the loop and we output no here. So yeah, that was one mistake of mine which caused in me not being able to solve this problem. And alright people, that does it for today's video. I hope you enjoyed this one. This is Arunabh Agrawal signing off. Thank you.